Okay, we're going to look at how to construct the ray diagram for a telescope. So probably the easiest way to do this is to start off by thinking about the eyepiece lens over here. Now, whatever the focal length is on one side, remember that it has to equal the focal length on the other. So I'm just going to do this roughly for now. You guys in the exam will have to do it precisely. Now, this is the easy bit. The easy way to do this is to remember that if I have, if the eyepiece lens has a certain focal length, so in this example, the focal length is from here to here, then the focal length of the objective lens will always be, for a telescope, will always be this distance here, because the focal point inside the telescope from the objective lens is on the focal point of the eyepiece lens, because the image is formed here. Remember that we want the image from the eyepiece lens to be at infinity, so the image is always formed here. So this is the focal point from the objective lens and the focal point of the eyepiece lens. So that's f0 and fe. So this is where the image is formed. So now it makes our life a lot easier because it's f0 and fe. So that's where we produce the image. Now the next thing is we need our parallel beams of light coming in from infinity. So you'll normally get something like 3 parallel beams coming in, either above or below the principal axis. It doesn't really matter, but they will always be parallel, because remember, because the light's coming from infinity, it's as if it was, it's as if they are parallel coming in. Now, remember, the easy way to do this is just to start off with this first beam, which is coming through the central point of the lens. Just carry it straight through. Remember, it doesn't get deviated, and carry it straight through to the next lens. Then all you have to do is make sure that the other rays are refracted so that they converge directly below this focal point. So we take this ray and make sure it converges below that focal point, and then take this ray and make sure that one converges below that focal point as well. Again, my diagram's probably a bit not very accurate, but you guys can make yours a lot more accurate. And then we form the image at that point. So that's the real image formed by this lens, and now we want to magnify that lens, and because and that now becomes the object for this lens. So now we need to produce an image on this side. Now, remember that for an object produced at an object placed at the focal point, the image is produced at infinity. So the rays will come out parallel, and they won't diverge or converge. So we have rays coming out parallel to each other. Now, because this is at a slight angle, it won't quite go through the focal point on this side. Because it's at a slight angle here, it won't quite come through the focal point. So I place it like that. And then my other 2 beams need to come out parallel. So I just draw those 3. And what I can then do is I can draw dashed lines going backwards that tend to look like they're coming from infinity. So, and they trace back so that we have an image that appears to have been formed at infinity. Now, you'll notice that if you look at the angle subtended by the object, theta here, so this angle in here, if we call that theta, theta of the object, of this one here, and then we have this angle in here, which is the angle subtended by the image, then you can see that there's an angular magnification, okay? And because it's an angular magnification, we use big M, so we're going to call that big M. Through trigonometry, you can see that if that's the height of the image, theta 0 is equal to the height of the image divided by the focal length of the objective lens, and theta I is equal to the height of the image divided by the focal length of the eyepiece. So the angular magnification simply becomes m is equal to theta I over theta 0. So we flip and cross multiply. So it's the image angle over the object angle. So you flip and cross multiply everything, and you get that h over fe is equal to times f0 over h, and then the h's cancel, and you're left with the angular magnification is equal to f0 over fe. So what that means is that you want an objective lens with a long focal length and eyepiece with a short focal length. Incidentally, these rays should all have arrows on, which I haven't been drawing, but they should all have arrows. These rays are solid because they're real, and these rays are dotted because they're coming from a virtual image on infinity. Right, done.